Good afternoon to everyone. So my name is Sadaf. Welcome all to the third episode of Data Science Club. Today we will be running you through with the life cycle of a data science project. So today we have with us Mr. Arihan Jain. He is a senior data lead data scientist with Zest Money. So Mr. Jain has over 6 years of top level experience working extensively with cutting edge technologies like machine learning, deep learning, data science, predictive modeling, which includes Python, R, and big data. He is also renowned analytical and data manipulation skill have enhanced his reputation as a tech throughout a leadership team, and he's also an intake hack of learning and understanding a new technology into a very short period of time. And today he will be running you through with how a end-to-end data science project will look like, and he'll also run you through with some of the very basic things or techniques which are required for a final year graduate to work on a data science project, right? So we will have this session for next 90 minutes. So wherein the initial 70 minutes, Arihan will run you through with the concepts and the life cycle of a data science, and then the last 15 minutes will be opened up for the questions. Okay. We'll also have a chat box enabled in the last 15 minutes of the sessions, and wherein you can pour in your questions, and we will take out some of the very specific questions which we can ask Arihant at the end of the day, right? I'll hand it over to Arihant now. It's over to you, Arihant.
Yeah, sure. Thank you, Sadaf, and thank you, Imarticus team, for the opportunity to come and talk on the project of the life cycle, which I hope will be beneficial for all the data science aspirant. I hope I am audible to every one of you. Maybe Sadaf, can you confirm? Am I audible properly? Right?
Yes, Arihant, you're good
Okay,
to.
okay. Let me share my screen, and I think without much delay, we will just quickly start this session. Okay, so let me just kind of share my screen, guys. Okay, great. So yeah, here we go. Okay, so great. So now we'll begin with the session. Okay, so first of all, thank you all of you for joining in here for this webinar on project or data life cycle of data science project. So as you know that my name is Arihant Jain, and I'm going to take this today's session. So broadly, I think you guys may have gone through the agenda which have been circulated across. But what we are going to discuss broadly in this session is that how should the typical data science project look like, right? From the beginning, to the end part, how that pipeline look like, point number one. Second, how that is kind of a thing you can learn and you can also implement your projects into the similar way, right? So we like if I talk about briefly about the data science pipelines, right? So in the data science pipelines, we have a business understanding. We'll talk about what is the meaning of business understanding and why it is needed. Then data collection process, data preparation, data cleaning, exploratory data analysis, and then doing the modeling, then doing the deployment, and then presenting our insights to the stakeholders, right? So all this part is something which we are going to cover. Along with that, I will also show you a broad flow in a Jupyter notebook that, let's say, if you pick credit card fraud detection as one of your projects, how you can stitch that project together for your college project as such, or for any data science project as such. So that's what also we are going to do in the today's session as such. Okay, so without much wait, let's start. So I'm sure that all of you are kind of aware about what is machine learning, but let me just kind of start with that first. That what is machine learning in the ecosystem here. So quickly talk about that. So when we hear this word called machine learning, right? What we say is that machine learning is the art of getting computers to act without explicitly programming them. So what this means is, like, let's say if I have to develop any website or any software, then I as a human or as a team, we have to write a lot of code, whether in Python, Java, or any other language, right? But when we talk about machine learning is a process where we are training a models or training a different predictive models which take a decision on the behalf of us. So definitely we are writing a code to train the model from the data. But once we have trained the model, then all the rules are being generated by the machines, which have been kind of applied on the real world data to take the decisions, right? So that's what the meaning of a machine learning is. And that's where I think in your projects you can kind of pick up any of the different machine learning project which we are going to talk about as we move forward, right? So broadly, I think three terms is something which you must be hearing a lot since last couple of years, or I will say since last 3 4 years or 4 5 years mostly, right? One is AI. Everyone wanted to talk about this, right? The second is machine learning, and the third is deep learning. And a lot of you have doubts also that, okay, hey, how machine learning is different than AI, or how AI is different than deep learning. So we'll talk about that quickly, and then we'll move towards the life cycle part of the data science project, right? So when we use the word called AI, it can be explained in multiple ways. Okay, we can give any name. Like for example, if we see a simplistic calculator, or the invention of a calculator for that particular period of a time, it may be a sum product for someone, that okay, you will be able to do some mathematics using a calculator. That's also some kind of a program, or people may call that as an AI. But let's try to understand in the today's context in 2020 how we define AI. So simple thing is that any technique which is able to mimic the human behavior is called an AI. Like for example, let's say we take a lot of decisions day in and day out, right? So we take a decision that okay, which route I wanted to take, for reaching from home to office, which credit card I want, which bank account I wanted to open a bank account with, which college I wanted to go and study with, right? So all these are kind of a decisions which we make, right? We use different information. Like for example, as a next step, you may wanted to go for a MTech or MS, or let's say any post graduation program for that matter, right? So you select that by using some variables in your mind. Okay, hey, that this is how the college should be. This is what I wanted to learn and all that, right? So if machine is able to give you that output, if you give the input to machine that okay, hey, this is my criteria, can you tell me that which college will be best for me, or which degree will be best for me? So if you are able to develop that kind of a system, that's an AI basically, right? So and machine learning is a subset of an AI technique. You can see from the diagram itself that AI is a superset here, and my machine learning is a subset, which is a subset of an AI techniques which use the statistical methods to enable machines to improve the experience. Right. So again, there are set of machine learning algorithms you can use to develop and develop different AI tools and try to mimic the human behaviors. Right. When we talk about the third layer, which is a deep learning is also a subset of ML in a way. And here, your techniques, the way you are interacting or the way you are trying to solve that problem differs. You are going to use a little bit more sophisticated methods. You are going to build a neural networks, which is a little bit more complex systems as such, right? So in a way, if you see all these three terms, whether we say AI, deep learning, or a machine learning, in general, we wanted machines or computers to train in such a way that they are able to take a decisions the way we take decisions today. Like for example, if I show you an image of dog and cat, we are able to understand that okay, this is the image of dog, this is the image of cat. Can I force machine, or can I train machine in a way so that machine can also tell me that this is a image of a dog, this is an image of a cat, or this is a image of a human being, or this is an image of a laptop, this is an image of a computer, this is an image of a, let's say, mobile phone. So if I am able to do that, that's an AI. Now I have a two choices: either I use a machine learning algorithms, either I use a deep learning algorithms. So we can use, so machine learning and deep learning is kind of a toolkit which you will learn over a period of time to apply the data science project, right? So I hope that part is clear to everyone. If not, if there are any questions, feel free to note your questions. So by the end of the session, we are going to take that question. We'll open a chat window where you can ask this, right? So broadly, if I talk about the machine learning part, which we are going to cover today, there are two parts basically to it. One is supervised learning, and other is unsupervised learning, right? And in today's session, we are going to focus much more on this part of the learning, which is my supervised learning. That is what I'm going to discuss today. So let's understand what is the difference between an unsupervised and a supervised learning. So let's say, for example, you have been given a one data set where you have been given, let's say, age of the property, let's say age of the property you have been given, and let's say you have given number of bedrooms in the property, right? And let's say one more information, square feet of your house, and let's say you have been asked to predict the house prices. So basis this three information which have been given, you have been asked to predict the house prices. Okay, now this kind of a problem, if you talk about where you know that what you wanted to achieve, you wanted to achieve house price, right? You wanted to kind of predict house price. Given if someone come up with this three information, you will be able to tell them the house price of the house, right? So this kind of a problem falls under the vertical of a supervised learning, SL. We call this as an SL also, supervised learning methods, where your target, what you wanted to predict, is also called a target, guys, right? Target. This is a target, and this is fixed now, right? So basically, this kind of problem is a supervised learning problems where you have a target defined. Okay, when you don't have a target defined, let's say if you in this data set, let's say if I have not given you this price, for example, let's say I have not given you this price, for example, I have just given you this three variables as such, and ask you to kind of find some insights from the data. Then when you don't have a target in your data set, then it's fall under the category of a unsupervised learning method. Okay, so basically in supervised you have a target defined, in unsupervised you don't have a target defined. Now in supervised learning there are two types of methods which we are going to learn and discuss in your projects today. One is called a classification, other is called a regression. So regression means what kind of problem? The similar kind of a problem like house price, where your target is continuous, where your target is continuous in nature, right? That's called a regression problems, right? Now when your target is not a continuous one, but it is like this 1 and 0. For example, let's say you are training a classifier to classify the dog and cat images. So basically, let's say 1 is dog and 0 is cat. So this is kind of classification problem. Let's say you are trying to build a problem, trying to solve a problem where you are trying to understand the credit card transaction is a fraud transaction or not. Okay, fraud or not fraud. Okay, so then again it's a classification problem, and you can call it as a binary classification because you have a 1 and 0 kind of a problem, right? So similarly in the unsupervised world you have a different technique, but in today's session we are going to focus more on the supervised learning part. Now let's see the supervised machine learning life cycle, how these life cycle, how this machine learning project life cycle look like for the supervised model. Now I'm sure that after I explain all these things, you will be in a position to go ahead and build your own models, or through, let's say, you can pick up any project and kind of work on these supervised machine learning projects. So I will take one example of one project and show you the demo also. Along with that also, I can give you the idea what data sets you can pick up, so you can go ahead, download that from the web, and try to do that as your final year project. Okay, great. So let's try to understand that how the data science life cycle look like. Okay, how's the data science life cycle look like? Okay, so the first thing first, so this is the first thing, which is a business understanding. Then there's the second thing, there's a third, there's a fourth, there's fifth, this is sixth and seventh. Okay, so all this pointers which I have written right now, we are going to discuss them one by one. Okay, so we are going to start with business understanding first of all. Okay, that first thing which will be needed in any data science project is a business understanding. Okay, that you need to have some business problem defined, that okay, for what analysis you are doing, for what purpose, what is your main purpose. So you can also understand that what is the main purpose for which you are doing all this collection of data or doing the analysis. Is the purpose clear to you? Is the purpose crystal clear to you? Are you asking the right questions? Like for example, let's say for example, Google is a company, right? They keep on showing you multiple advertisement, right? So the question is the advertisement which we showing as a company are relevant to the users? Okay, so the question I have is the advertisement which we are showing to the users, okay, are relevant or not? And how we will understand whether they are relevant or not? How many people are kind of clicking on that, right? Once you have this kind of a problem statement defined, then you will understand about the business, you will understand that how the business works, what is the domain understanding about the business. So again, as you see that machine learning is a very vast field. In a lot of domains it is being used, like if you talk about banking, if you talk about telecom, if you talk about insurance, if you talk about IoT industry, if you talk about logistic industry, supply chain industry, e-commerce industry, you just name the industry and you will see that there are umpteen amount of use cases which is kind of available, for you to solve it, right? So the first part is a business understanding. The second part is, once you have the business understanding, then you define a strategy to collect the data. Okay, so collect the data in the form of an CSV files, Excel files, text files, or let's say databases, and so on and so forth. We'll talk about that more in detail. So I'm just giving you an overview, guys. In the next few minutes, we are definitely going a little bit deeper in all of the segments one by one. We are going to understand in detail about this segment, and so on and so forth. Once we have collected the data, you have a collection, data collection strategy in place. Then you go and talk about the data preparation, that how you should prepare your data. See, it's a very simplistic thing, right? If you think, let's say, if you wanted to cook something today, let's say some delicious dish, okay, then what you will do, right? You will understand first of all what you wanted to cook, right? Which is your business understanding in a way. Then you will collect the ingredients, right? You will collect, let's say, if you wanted to make, let's say, some dish, some delicious dish, you are going to first collect some ingredients like vegetables and other masalas and so on and so forth, right? Then you prepare them. What is the meaning of preparation in that context? You know that, okay, in what ratio you wanted to mix and all that stuff, right? You are going to do that kind of a thing. So that's the same thing here. When you talk about data preparation, you need to prepare your data. You need to understand that what are the missing values in your data, how your data look like. You need to go a little bit deeper. You need to understand each of the variables in your data, and so on and so forth. Once you have done that, then you move to exploratory data analysis. Now, in exploratory data analysis, what we do, like for example, the data is present in the form of a CSV files, right? Now I wanted to plot a beautiful graphs. The beautiful graphs, like let's say a simple line chart will do, or let's say a bar charts, or different kind of a chart which we can kind of plot to understand the trends in the data. Like for example, let's take this example of credit card fraud detection, okay, and let's try to understand this in better way. So let's say you are working on a credit card fraud project, okay. So let's say you have been given a data set where each of the transaction have been given to you, and it has been told to you that that particular transaction is a fraudulent transaction or not, right? Now let's say there is an amount given to you as a variable there, okay, amount is given to you there. So now you can kind of try to plot a graph with amount and the fraud. You will try to understand that, okay, is the fraud happening on a higher amount, or is the fraud happening on a lower amount, or what is the amount range on which higher frauds are happening, right? So you can easily do that by creating multiple tables or by multiple charts like bar charts. You can create amount, different buckets of the amount, and try to see that what is the fraud percentage in them, which will help you in understanding that where the real problem is. It may be possible that the amount which is higher in nature, we may be seeing a higher fraud there, right? So all this kind of an exploratory analysis is something you will cook in here, okay. You will cook in the exploratory analysis. Then finally, it's the time to all the hard work which we have done till this point of time, 1, 2, 3, and 4, all this hard work which we have done, finally we wanted to aggregate them together to model, okay. To model, again, here a lot of knowledge is being needed of different machine learning algorithms, different deep learning algorithm. But don't you worry about this. When I will go in deep on all these topics in the next few slides, I also mentioned the skills which you needed. So some of the skills you may have right now, some of the skills you may not have. So don't worry, but at least I will mention some of the skills which you can learn and then try to create and try to solve the data science projects using this kind of a pipeline which I'm explaining, right? So here is the real magic happen. So here is the real magic which happens where we create a models. Like for example, in the case of a fraudulent transaction, what kind of model I will build? That, okay, let's try to predict when the transaction is happening, that what is the probability that this transaction is a fraudulent transaction or not, right? So that kind of models or intelligence we can build it. However, whenever we build anything, we need mechanism to evaluate it. Like for example, when we build a building also, we wanted to understand that how good that building is, how for how much period of time it is going to survive, right? So in the similar way, the next part is the model evaluation part, where you need to understand that how good your model is, okay. Is it like if I start using this model, after 3 months it is going to go bad, or it is not going to work? So all these questions I need to answer very carefully before I think of using this model, okay, finally for my use case. So that's a model evaluation. So simplistic ways I given an example. That's in simplistic way you can think of model evaluation is what? Model evaluation is is a simple phenomena where you try to understand how good your model is, right? And then the last part basically is model deployment. So whenever you develop something, uh, you wanted to present it to the business, as well as you wanted to put that model into the production environment. Now, what is the meaning of production environment here? That so that your company, or let's say you have an app, you have a website where it can be used. So that part is called a model deployment. Again, this is very, very important skill, guys. Kind of underrated skill for a data scientist, but this is again a very, very important skill. I will talk about the frameworks, programming languages, and the different libraries which you can use to learn about a model deployment, right? And so basically in model deployment, what you can do is you can deploy your model and give it as a website link, okay, where people can come and fill the inputs and they will get the output. Okay, so in this way, you can think about the model deployment here, right? So this is the overall modeling or any data science life cycle pipeline look like. Now we are going to do what? We are going to go deeper in each of these topics and get a deeper understanding on each of these topics. Okay, and then after that we'll see the demo. Along with that, we will also see that for becoming an expert in all of these topics, okay, all of this topic, what skills you need. Okay, we are going to discuss on that also, because some of the skills I'm sure you guys have developed over a period of time. Some of the skills you can develop over a period of time if you know that what skill is needed in that particular area. Okay, great. So great. Let's move on. Okay. So let's start with business understanding. See, all the fuzz about data science, machine learning, AI is all about because what value you can bring on the plate. Okay. What value all the models which you are developing, all the insights you are doing, all the analysis you are doing, what kind of a business value you can bring it to the business, right? So basically, that's where business understanding is very crucial. But let me try to kind of explain this term. What is the meaning of business understanding? Okay, what is so the typical question here may come from you is that, do I need to understand the complete business end to end? No, you don't have to. I will say that you have to more understand about the domain in which you are trying to solve a problem. Like for example, if you are trying to solve a problem in the banking world, okay, then you need to know, like for example, the example which we have taken of fraud detection. Let's say I will write it here. Let's say you are trying to solve a problem of a fraud detection. Now in this, you should know that, okay, how many different kind of cards company is offering. Okay, how many different type of a card company is offering. Okay, what is the annual fee for that cards? Okay, how the payment mechanism work, whether all of this card can be used online or not. Okay, whether this card can be used international or not. Okay, so all this kind of information you need to understand. And also before that, you need to also understand that how we are kind of qualifying people to provide these cards. Okay, how we are qualifying people. Okay, that's also the question you need to understand. So when you try to understand and ask each of this question together, in a way, basically you are trying to understand more about the domain. Okay, that what kind of cards you are kind of giving, when the frauds are happening higher, and all that kind of stuff is something which you need to understand. So basically here it's very intuitive, because credit card or banking is something which we do day in and day out, right? Now let's think of the example of an healthcare industry. Okay, now let's say in healthcare industry you have been asked to predict the cancers, and there are, like, let's say 10 to 15 types of cancers, okay, which you need to predict using your data which have been given to you. Now again, this field is not very intuitive. You need to understand that, okay, what are the different type of cancers which can happen, what are the how they different from each other. In like one type of cancer, what are the symptoms? In other types of cancer, what are the symptoms? Now you may think that, why I need to worry about all this? Because this will help you in understanding the data better. And until unless you won't understand the data, you won't be able to ask the right questions. Asking a right question is a key for successful projects in a data science world. Okay, if you don't ask the right questions, you don't get the right answers. So your models are definitely not a Spider-Man, okay, which can give you the answer to any questions. So that's where you need to be very peculiar, very specific, very smart in asking the right questions, so that you can define your problem in a better way. Again, trust me, a lot of projects are like kind of go into a failure mode because of this particular reason, when people don't understand the domain, and then don't frame the right questions. Okay, so right framing of the question is very important. Okay, Because once you do a right framing of a question, you can convert the business problem which you have in hand into a proper data science problem, and then take by using the different tools and techniques which is available. So now the question which you may ask again to me is that, this looks good, Aryan, but the point is where we can learn all these things. Okay, where we can learn all these things. So that's where I have mentioned couple of skills which you need to develop here if you wanted to be good at it. Is you should work on your structured thinking. So what is the meaning of a structured thinking? Whenever you have been given any problem, or you can see, no one has to come and give you a problem. Just think about that. There are so many different problems out here in our surroundings. Okay, and you can try to take any of the problem and try to understand that how you can solve using the data. Okay, and you then, in structured thinking process, you can try to break that problem into multiple chunks. Okay, now for example, let's say in the credit card fraud data set. Okay, you have been given this problem in the company you are working, that fraudulent transactions are increasing day by day, right? Now if you have a good structured thinking, you will first break this problem into multiple chunks. That, okay, let's try to understand how was the fraud in last 2 years. Okay, how they are growing, what at what rate they are growing, what are the different factors which has changed in last couple of months, in terms of we are delivering the card, in terms of we are giving the card to the customers, what has changed in the processes. So all these questions you need to answer. See, again, data science, a lot of people think that, okay, data science life cycle is getting a data, feeding into the algorithm, getting the output, and be happy and enjoy. No, it's not like that. The first phase is very, very important, where you need to ask the right questions. So when you have a structured thinking, so develop a structured thinking. How you can develop this? You can develop by solving different guesstimates exercise which is available on the web. Okay, if you just search it, different guesstimates, different puzzle solving, puzzle solving helps in developing your structured thinking. Try to solve different case studies which is available. Okay, pick up any case study and try to break this into multiple chunks and solve them, right? Similar goes for a critical thinking. So critical thinking and structured thinking. Critical thinking is more of paying attention to details. Small details matter. Small, sometimes your project needs improvement, and if you don't have this keen ability of focusing on small details, you may not able to improve the accuracy or improve the performance of your particular solution which you have developed, right? So critical thinking also come in there. Now the third thing which is also very important for you guys, as you are not working, let's say, somewhere, then how you can gain the business knowledge? By reading a lot. By reading what? There are a lot of blogs, there are a lot of companies, there are a lot of consulting companies which publishes very good blogs about the different business case studies, different analytical case studies. So one of the blogs which I follow very much is McKinsey Insights. They keep on publishing very, very good articles every day. They publish 4 to 5 articles a day. You can go ahead, read about them, try to understand, and then brainstorm with your folks. Ask the different people out there on the social media, LinkedIn and all, that, okay, hey, can you help me in understanding this, that this, how this work in this particular business area. So this type of things are very important for you to kind of understand in detail. Okay, but again, I know that this part is something which you may not be able to do it fully in your projects, but whatsoever project you wanted to pick from the list of the projects you have in mind, just think of this part also, that how easy for you to get the business understanding about that particular problem you're working with. If you go on Kaggle as a website or any other data platform, as such, you will see that there are tons of projects which is available. But be very important point you need to keep in mind is that, do you really understanding what's the impact, or what is the business or domain understanding about that problem? Okay, so that's very important for you to understand. The second part is, once you have understand the business problem well, then the second part is not very difficult to be honest. The second part, if we see, is the data collection part. Okay, what we call as a data collection part. Like, for example, I will give you an example. Let's say about the credit card fraudulent problem. Let's say you have got this business problem that fraudulent transactions are increasing. Okay, so let's say you try to ask couple of questions to understand the domain, the way I have shown this, that, okay, on which particular card type it's happening, on which particular card type it's happening, what amount relationship, and so on and so forth. You can ask different kind of a questions. After that, all these questions which you are asking is kind of laying a ground for you to collect the data. Okay. Now, in a lot of competitions which you work on Kaggle or any other platform, generally you have been given a CSV files and Excel files, right? Someone will come and give you the Excel file and the CSV file. But in the real world, it doesn't happen like that, right? Because in real world, you don't no one will come and give you the CSV files like this. You have to collect the data. So where the data is lying, you need to understand that. Okay, whether where the data is lying, let's say in databases. So which is the database? Is it a Oracle database, Redshift database, or what are the different data set database where this data are lying? And definitely this data will be lying in some tables, so you need to understand about that tables and all that stuff in the real world. But for you, I think this part is not very much involved, because generally in the open source world, uh, you get the CSV files directly. But you need to know that once you have a clarity of your business understanding, data collection becomes a very simple exercise, where you need to just think of the different questions which you are asking, and you need to think of that. Okay, hey, where is that data? Like for example, for fraudulent transaction, one of the variable you need to find out where that is lying in the databases is that at what time the transaction is happening. Okay, it may be possible that the fraudulent activity may be happening in the odd times, right? Because the people who wanted to hack and do the fraudulent transaction, they may be doing this on some odd times. Okay, but we need to validate this from the data. Okay, also you need to know that, okay, where I can get the weekday information, whether the fraudulent transaction happened on weekday, on which location the fraudulent transaction happened, which channel the fraudulent transaction happened, and so on and so forth. So again, see, this part is more on understanding how you can collect your data. Okay, so in the real world, it doesn't happen like that, simply that your data is lying in one CSV file. It is lying in multiple databases or multiple tables, you can say, and then you reach out to all these tables together and kind of create a final CSV file which you're going to consume. But this part, let's say this is a database, this is table 1, this is table 2, this is table 3, this is table 4. All this thing you need to know. Again, here there is a very heavy role of a databases, in most of the cases in the supervised machine learning world. So that's where you need to know that what are the different type of databases available, how you can fetch the data from the different tables. And that's where you need to have a SQL skills, which is a structured query language skill, SQL skills, right? Again, I'm saying that if you are bringing a data set from Kaggle, you may not need this. But again, if you wanted to qualify yourself as a data scientist to join the industry, you need this. Okay, so I hope you are getting this difference, that how this is different in the real world versus the competitions which you do, right? And then the next thing is the skill on Python and R. This is again going to be very important. You can connect the Python languages directly with databases. There are packages. So one of the famous package which you can use is SQL Alchemy for connecting your databases with the Python language. So all these things you can do it and then try to collect the data. Okay, so this is the how you can kind of create your data collection part. Now the third part, I think from here you will feel that you have a lot of things to do. The third thing is data preparation. Okay, now let's try to understand what is the meaning of a data preparation. Okay, so what we have done till this point of time, we have a business understanding in place. Let's say we have a business understanding in place. Point number one, we have a data collected. Okay, so we have collected raw data. I will call this as a raw data. Okay, that I have collected the raw data. Now raw data doesn't have any value. Like for example, when your crude oil came, right, crude oil come, right, the real value after processing it, when we'll get a petrol, diesel, or any other kind of a fluid there, right? So with the raw data, there is no value. You need to create a value from it, and that's where you need to prepare your data. So what is the preparation of the data look like? So first, let's try to understand. First thing which you need to look at the data when you collected the data is that the data which you collected is representative of the problem to be solved or not. Like for example, I will give an example for this particular explanation, that what I meant by this. Like for example, let's say you're solving again this problem: credit card fraudulent transaction. Okay, fraudulent transaction data set. Okay, now let's say you have collected one information about a customer, about, let's say, whether the person is okay, so let's say you have collected multiple information. Let's say you have collected what amount of transaction person was performing, what is the age of a person, okay, at what date the transaction happened, which was the fraudulent transaction, at what location the transaction happened. But let's say you are also collecting that what is the name of a customer, okay. So this name of a customer is not very relevant to the fraud, right? Because what you are going to define from the name, okay, or name or surname, let's say, okay. So even if you are collecting this data point, this is not going to help you in any way with respect to fraud, okay. But yeah, location is going to help you, because it may be possible that there are a few locations which are more prone to fraud, right? So here surname and name collection is not very important, though you can collect it. But that's what I'm saying, that you need to think of that the data which we have collected is really is representative of solving the problem which is there on your plate right now. So if you have a fraud problem, okay, fraud transaction problem, fraud prediction, in a way, all the data which you have collected is kind of helping you to represent your problem better or not. If it is not, see, if you have the data like, okay, what are the mutual friends of that particular customer, or what is his friend, what is his wife name or girlfriend name, right? It doesn't matter, right? In that. So again, you have to be very relevant that what data is relevant, what data is not relevant, at least at the beginning. Though there are some statistical technique which we are going to learn, but you have to be very sure that, okay, while preparing a data, that this is the right data which you are collecting for the problem you wanted to solve, right? Then after that, you can kind of understand your data a little bit more with the help of a descriptive analytics. So what is the meaning of a descriptive analytics? Like, for example, let's say if someone have given an amount, okay, to you amount in your data set, right? For a credit card fraud data set, you can kind of understand that, okay, what is the mean amount, what is the median amount, what is the 75th percentile value at the amount, what is the max amount, and all that kind of thing. So that kind of things are something which we call as a descriptive analytics, where you are going to apply the funda of a descriptive analytics, which is like mean, median, max, all the statistical way to understand your data better, right? So let's say if you have a date time object present, then you are going to see that, okay, what day of the week it is, and all that stuff. Then after that, you can plot a different visualization also in this stage also, or in the next stage which we are going to discuss. Other than that, you need to remember about few of the things which is going to be very important. The first thing is handling missing values. So again, the real world data which we collect generally is full of missing values. So full of missing values by design or by error. Okay, both the thing it can happen. So what I mean by that is, let's say you have a data set again for a credit card fraud data set, and you have, let's say, 100 columns, okay, 100 columns, and you may have seen that 70 columns have no missing values, but 30 columns have some missing values. Now in this, missing value means that data is not present. You can also represent this as a NA, okay, simple NA or null. You can also call this as a NA or null, right? Now this 30 the columns which have some missing value, you can try to understand what percentage of data is missing, whether 1%, 2%, 5%, 10%, 30%, or what is the percentage. So all this analysis you need to do, which is handling missing values. Then handling outliers. Now what are outliers? What are outliers? Statistically, if you have read it, the outliers are outliers. So in a simplistic way, if I talk about what are outliers, outliers are something which is away from the crowd, right? So which is different, right, from the crowd in a way. So in the statistical sense also, we define outliers in a similar way, that the value which is very different from the overall or majority of the population is called an outliers, right? In a statistical sense, if you have read about the statistics in detail about outliers, it has been said that any value which is above 1.5 IQR, which is interquartile range, are being termed as an outlier. So again, the idea here is that you handle the outliers. Now there are so many different techniques out there to handle the outliers. Okay, then you apply all that methods out there to handle the outlier. So what we are discussing basically, guys, is that what you need to do in the data preparation stage. What you need to do in the data preparation stage. If there are any duplicates, then you have to handle them. Handling any spatial characters, right? Um, then removing column with zero variance. Let's say one column have the same values all across, then that column is not something which is going to help you a lot. So you need to remove that also. So in nutshell, data preparation is very, very important part of the pipeline, because you are kind of doing a cleaning. So I will kind of say this, that this is data preparation and data cleaning. Okay, you can kind of understand that way. This is a data preparation and data cleaning exercise which I am doing, right? And the skills which you need here is, so in Python there are this packages called pandas and numpy, and statistics is something which you kind of need here, guys. The skill on pandas library, the skill on NumPy library, and the skill on statistics is something which you will need for sure here. Okay, I hope all of you are with me and following me. If you have any questions, I'm sure you must have any questions for sure. Please wait till the end of the session. We are going to take the questions around 4:15. Uh, we are going to take the question. Okay, great. Let's keep on continuing here. Okay, and now let's talk about the next part of the thing, which is EDA and data storytelling. Okay, so we have talked about data collection, data preparation. So what we have talked about till this point of time is business understanding. We also talked about data collection, right? And then we have talked about data preparation, right? Now we are going to talk about the next thing, which is EDA and data storytelling. Again, a very, very creative way of doing the things, that how you can visualize the trends in your data. Okay, how you are going to kind of visualize that what kind of trends are present in your data. So that's where we call this as a EDA. EDA means what, guys? EDA means exploratory exploratory data analysis. Exploratory data analysis. Now what you do in this is, you try to understand again a deeper patterns which is present in your data. Okay, deeper patterns which is present in your data. Like for example, in the case of a credit card fraud detection, the example which I have taken. Okay, so if I wanted to kind of take that as an example and show you, so what you will do in that case is, you will try to understand, let's say, the amount. Okay, so you will try to plot a graph like this, let's say, where you will have an amount of transaction which is happening. Let's say this is 10,000 rupees, this is 20,000, this is 30,000, and so on and so forth. Let's say this kind of a data is there. And then basically, let's say you are trying to understand, this is a fraud percentage, let's say, on the y-axis. Y-axis is, let's say, your fraud percentages, and x-axis is your amount of transaction which is happening. Then again, you are going to understand that what is the pattern you are seeing. uh, is the is the fraud very high in the lower amount, which is 10,000, or very high, let's say, in the 1 lakh kind of an amount, or 2 lakh kind of an amount, basis the fraud percentages. So you will try to plot a graphs out here in this xy plane by keeping the x-axis and y-axis, or let's say a line chart or a bar chart kind of a thing, or a histogram kind of a thing, where you wanted to understand that what kind of a trend are you seeing between a amount of transaction and a fraud. So this is one example of a EDA. This is one example of a EDA. Okay, you may also wanted to see, let's say, one more example of EDA I will give before I move on. Is, let's say, that weekday or weekend. Okay, so let's say you have a date of the transaction, and let's say you have created this simple thing out here, which is, let's say, weekday and weekend. Okay, and then you have a fraud percentage out here. Now you will see that, okay, on weekday you have some fraud percentage, on weekend, let's say, you have some fraud percentage. I just draw it an hypothetical example. Okay, just to understand that, okay, is the fraud happening higher on a weekdays or weekend. At least this will give you an info, right? You can break this further, right? You can kind of plot days also: Monday, Tuesday, Wednesday, Thursday, and so on and so forth. And here you can keep fraud percentages. So all this kind of a things, guys, you can kind of do using an EDA. And this analysis which I am doing is kind of known as a univariate and bivariate analysis. Univariate, when you do a analysis with a single variable. Bivariate is something when you do analysis with a two variables in a hand. Okay, correct. Now, so this is again, if you think of, this is more of a hold where you wanted to understand more about your data. Okay, so more and more EDA you are going to do, more and more analysis you are going to do, you will be in that position of understanding your data better. Okay, so some of the examples I have kind of shown in. But what skill you need for this? Okay, what kind of skill you should develop if you wanted to do this part in your data science project lifecycle pipeline. Okay, so the skills you need to learn is of course Python and R, which is a mandatory skill. I am talking about that from beginning. Then the second skill which you need is pandas and numpy. Again, a pandas and numpy packages are very good packages to know. Then statistics, so idea on both the things. One is descriptive statistics, which I talked about, as well as inferential statistics. Okay, as well as inferential statistics. Then data visualization tools, which is like in Python, you have a matplotlib library, Seaborn, Plotly. All this kind of things are something which is very helpful in this particular part of a data storytelling. Okay, so do remember that. Then you can learn visualization tools also. So you can do a lot of visualization using this libraries. But if you are interested, you can learn tools like QuicklyView or let's say Tableau kind of a tools also, which will help you in doing this visualization better, right? So this is also a few of the tools which is available for you to do that exercise. And the most important skill is creative mindset. Always think that how creatively you can present your analysis. Like think on all the angles about that. Again, this is also having the connection with my first slide: structured thinking, creative, critical thinking, business understanding, domain understanding. Okay, so this is this part. Now the next part which we are going to discuss now is modeling. Okay, what we are going to discuss now is modeling. Okay, so this is the final stage for every data scientist is like kind of very interested in. Okay, because that's the area you are going to build models on. Like for example, in our case of credit card fraud transaction, let's say I have done a data collection, I have understand the business, I have prepared the data, I have done an EDA also, I have plotted a lot of graphs to understand the data. Now what? Now I have to develop a model which I will call as a predictive model, which will predict that what is the probability. I repeat that it will predict what is the probability of the transaction of that particular transaction to be a fraudulent transaction, right? So that part is something which is kinda done at this stage, which is called a modeling stage. So again, in the modeling stage, you have a lot of tasks. Like for example, you have cleaned your data, you have done missing value imputations, you have done outlier treatment, and all that stuff. Then once you got the data, let's say final data which you have, so the final data will look like how? In the form of rows and columns. Let's say you have couple of rows out here and couple of columns, right? After that, you wanted to feed this data. You want to feed this data to algorithms. Now, in the world of algorithm, there are so many different algorithms out there in the machine learning world for classification as well as for regression problems. So here, what you do in this particular stage, let me just kind of talk about that. The first task is that you divide your data into training, test, and validation. So what this means, guys, is, so as I told that it's very important that whatsoever you are developing, you should test this, right? Test this on some metrics, right? Similar way, the example of, let's say if you are cooking something, right? By you are cooking something, then how will you know that it is a good, right? You will go to people, right? You will go to two different people or three different people and say that, okay, can you test this for us and tell us that how good it is, right? In the similar way, what we do is whatsoever data set we have, okay, we divide this into multiple parts like training, test, and validation part. So what we say is that, okay, if we have, let's say 10,000 rows, we say that, okay, let's say I have a 10,000 rows. Okay, what I will say is that, okay, 7,000 is something I will use for training. 1,000, let's say I keep it for testing, and 2,000, let's say I keep it for validation. Or you can keep actually one also. You don't have to keep test and validation separately. Or I can also say that, okay, I can simply keep I don't take a validation for now. I will just take my test data and keep it as a 3,000 rows. So basically what this means basically is that on the training, the 7,000 rows, you are going to train your models, means train your algorithms. You will apply an algorithms and train your model, and on this 3,000 you are going to test the performance in the similar way, right? Because the person who is cooking, right, he should not kind of test the model by himself, right? So in the similar way, on which we are training, because this is the training data, so we should not rely on the result on this. We should rely on the result on the test data, which is the other data. So in short, this data is something which will never go into the model. We won't use this data for training. We'll use this data point for training and then test it on this particular 3,000 data set as such. Okay. There are so many different techniques again for one more task. Let me talk on that. Now, again, when you got the data set here, okay, for training your model, okay, what you need is, first of all, you need to divide your data, as we have discussed. First is divide your data, okay, that's one thing. Second is, let's say you have got 1,000 features, okay, let's say, sorry, 1,000 features, okay. 1,000 features means 1,000 columns. But the question is, are are all the columns relevant? Are all the columns relevant with respect to what? With respect to the problem I am solving. Let's say here I am solving fraud. So with respect to fraud, if not, then can I reduce this 1,000 to some number? Because let's say if out of this 1,000, if I know by some technique that only 400 are of importance, 600 are not like helping very much. 600 is not something which is helping very much. Okay, and I don't wanted to use all the 1,000. Then you can use different techniques, which is called a feature selection methods. What we call this as a guys is a feature selection methods. So what you can do is you can use different feature selection method. And what is the purpose of this feature selection methods? This feature selection method help you in reducing your data from 1,000 columns to some, let's say, 400 or 400, or let's say 200 rows kind of, or 200 columns kind of a thing. Okay, so this process is called a feature selection process. Again, you don't have to do it manually. There are techniques available. So there is one technique called RFE technique, which is called a recursive feature elimination methods. Then there is a method called IV, information value. Of course, I don't wanted to go in detail on this, but I'm just listing for this session. I don't have much time to cover them, but at least I just wanted to write a pointer so that you can go back and you can learn about that while doing your project. If you Google it, you will find a lot of material which is out there for this techniques, right? Then once you've done this, then the next part is to identify which type of problem it is, whether it's a classification problem or whether it's a regression problem. You will know by looking at the data you have, like what you wanted to predict. Like in house prices you wanted to predict, then it's a regression problem. If you wanted to predict 1 0 kind of a thing, then it's a classification kind of problem. uh, then algorithms, there are so many algorithms. So if I name them, there are like more than 25 algorithms I can name now. But some of the algorithm you should read and make your skill upon is logistic regression, linear regression, then your decision trees. Okay, then your decision trees, random forest. Okay, random forest. Okay, then SGBoost as a technique, KNN, support vector machines. Now, what is this algorithms? So this algorithms are nothing. It's some mathematical mathematical algorithms in a way which have been already coded and available to you. So the library in which all this algorithms is available mostly is scikit-learn. So 95 to 98% of all these algorithms will be available in this particular package. Why I'm writing a name, guys, so that you can write it down, you can take a snap or whatsoever you wanted to do, so that you can read about that. See, if you don't know whatsoever content, guys, I am talking about, maybe some of you know very well, some of you know partially, some of you may not know anything. But don't worry, just follow me. Write down all these things after the session, Google them, and try to think that how you can incorporate all this thing in your project. Okay, and as I return, try different things. And the skills which you need is to know about this algorithms. So you can pick the simplistic algorithm if you have not done any modeling, like logistic regression and linear regression and decision trees to begin with. And you go to this particular library in Python. It's a very famous library in Python to build a model, which is called a scikit-learn algorithm. Okay, so this is the part, guys, till the point we have reached, where we have talked about the model building. So again, just a quick recap. Okay, we understand about a business understanding part. Then we discuss about data collection. Okay, then we talk about data prep, right? Data prep. Then we talk about what? Then we talk about EDA, right? EDA and data storytelling. Data storytelling. Then we talk about the modeling, where you need to know a lot of machine learning models. A lot of mathematics is also involved here, guys. So you need a skill on mathematics also. Like you need to know about linear algebra, matrix transformations, calculus, a little bit of calculus also. Then finally, I have developed the model. Now we are coming on this topic, which is called model evaluation. Model evaluation. So what is the meaning of a model evaluation, guys? Model evaluation is a step where we are going to evaluate our model, that how good our models is. Now, all these things which you are seeing here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all are like kind of a methods or metrics, basically, you can say, to evaluate your machine learning model. Okay. Now, don't get scared. All these metrics are not very difficult to understand. Some are very easy to understand also. Okay. You can, if you read them, you will try to understand them. But I can help you in classifying one thing at least. From here till here, till this point of time, they are all a classification matrices. So like for example, let's say if you are building any classification model and you wanted to know that how good your model is, see, in a layman term, how will you know that how good your model is? So let's say if you have 100 data points, okay, 100 data points, out of which let's say 30 is 1 and 70 is 0. Okay, let's say okay, and now let's say you have made the predictions. So how will you know that how good your model is? So your criteria of goodness of your model will be what? If the actual is 1, actual class is 1, and if you are predicting as a 1, then it's good. If the actual class is 0 and you are also predicting as 0, then it's good. I'm talking about a classification problem. If actual class is 0 but you are predicting as a 1, then it's an incorrect prediction, right? Similarly, if actual class is 1 but if you are predicting 0, then your prediction is incorrect, right? So what you are interested in is these two things, right? What you are interested is in these two things, 1 1 and 0 0, where you make both the classes predictions correct. So in a way, there are different ways to handle this matrices, and uh, this matrices which you can read about. The famous, which is very famous, which you should be reading about, is AUC, guys. AUC is very famous. Even precision and recall. These three are kind of very important matrices to know for the classification perspective. This below 4 matrices, guys, I have written is for a regression. So like if you're working on a house price kind of a models, then this matrices is something you will need there. Okay. What this evaluation matrix, guys, is this evaluation matrix help you in understanding how good your model is. Like for a regression problem, let's say if your house price is 20 lakh rupees, right? Uh, so let's say if your house price is 20 lakh rupees and you are predicting as an 18 lakh rupees. Okay. You are predicting as an 80 lakh rupees, 18 lakh rupees. So what is the error? The error is 20 lakh minus 80 lakh, which is 2 lakh. So this is the error. So you need to understand all this in a matrix way. That's where all this matrix help you. Again, guys, I'm sure you may not know all of them, but again, the idea is that you take a note of them and try to understand all of this or some of this at least 4 5 matrices out of this by reading about them and then implementing your project. Okay, great. So then the next part comes is called a model deployment. Okay, what the next part comes in is a model deployment. So basically, if you see the funnel of any machine learning pipeline, as we have discussed this, that first you start with a business understanding, right? Business understanding. Then you move to data collection part, right? DC, I will write. Then you move to data preparation part. Then you do a lot of EDA on the top of it. EDA on the top of it. Then you build your models here the part where you will build your models, model building. Then you test your models. Then you test your models, model evaluation you do. And then finally, all this thing we are doing for what? For the end users, right? So that you can kind of tell them that, okay, this is what I have built, or you can showcase in form of a chart, in form of a dashboards, or you can showcase in the form of a website and all that. So again, that part is called a deployment part. So the final part here is model deployment. So what is the meaning of a deployment? Okay, let's try to understand this pipeline. So model deployment is called a process of putting your machine learning model into the production environment for use, for the final use. Like for example, if you have developed a fraud transaction model, okay, credit card fraud transaction model, right? Now for credit card fraud transaction model, if you put this into production, means what? Whenever any transaction is happening, that will go to your model and try to ask that this particular transaction is a fraudulent transaction or not, right? So if that part you are able to do, it means that you have deployed your model. The simplistic way I'm kind of explaining here, right? So the purpose of deploying your model is so that you can make the prediction from your model to the other users, management, or other systems. Okay. Again, in that, if you wanted to read more on that, you can read about the Flask framework. This framework is very good to create an APIs in Python. This is again a framework in Python. You can read about that. this help you in creating an API. This pickle is a term to store or save your models. What's your models you are developing? If you wanted to save them, pickle is a method which help you in doing that. So read about a Flask. So Flask can help you in creating the APIs very fast and help you in deploying your models. Help you in deploying your models. Okay, so that's what you should learn about. Right now, finally, after doing all this, now it's the time to present this analysis. Right. So finally, when you reach to this stage where you have done data understanding, business understanding, model building, and so many statistical analysis, I know that in last 45 minutes I talked about a lot of terms, and some of you may be feeling also who have not known any of this thing, that okay, hey, what we are talking about, right? There's so much things to learn. Exactly, there are so much things to learn, but finally this part is something which I think a lot of you will concur with me or agree with me, that here we just wanted to put this into a one report. That report can be a Word document, that remote can be a PPT formats, in a very very succinct manner. You wanted to say that what you have done from first part till the last part. You can mention that what kind of techniques you have used, what kind of data preparation you have done, and all that into final report. uh, in real world also, this have been presented in the form of a PPT, but let's say if you are doing in your college project also, I strongly suggest that you create a very very detailed report which you can submit to your profs. Also you can share with the people on the different social media to share that okay, this is what you have done. Okay, great. So this is the last point on this, guys. Now we will go to the notebook, and I will show you how how you can kind of create your model or any project, and then we'll talk about briefly on couple of projects which you can pick from Kaggle, and then we'll open for Q&A. So in the next 15 minutes I will be able to cover all of them. We are right now at 4 p.m, so 4:15 I will be able to cover that, and then after that we will open up for a Q&A. So stay there till the end, guys. There is going to be a lot of interesting talk, and I know you have for sure a lot of questions which we are going to answer. So I will do one thing. I will just share my notebook now, which I wanted to present. Guys, just give me a sec. So I will show you that all these things which I told you right now. I hope my screen is visible. Sadaf, my screen is visible of the notebook. Can you please confirm?
Yes, sir. Yeah.
Okay, great. Okay, so guys, what we have done till this point of time is we understood a lot of theory, right? Understood a lot of processes, a lot of stuff on life cycle. But let's see that how that work in the coding part. One disclaimer, of course, with the time which we have, I cannot kind of cover each and everything in detail. But at least the main motivation of showing this in this particular session is to show that how I am applying each of the parts which I told in the slides into the form of a coding form. Okay, so this is, let's say, a credit card fraud detection pipeline we are trying to build in here. So this tool which you are seeing is called a Jupyter Notebook, which comes inbuilt in the Anaconda software. So if you use Anaconda tool or Anaconda software, then you have this already available. You can add comments also here. You can write code here also. It's a very beautiful, beautiful tool, I will say. Okay, for showing your analysis or sharing your analysis. So let's first start with loading the libraries. So all the libraries, if you remember, I talked about is NumPy, Pandas, Matplotlib, Seaborn, right? All this I'm loading it. This is the way I'm loading it here. Okay, and I'm just running this. Okay, and then we'll load one data set, which is credit card .csv data set. Again, here there are two parts which we need to know in detail. One is business understanding, which in this case is that what we wanted to do here. We wanted to do here is to predict the fraud, because the fraud is increasing. Online frauds are increasing in a way, and we wanted to build a system which can control this fraud. Right, that's a business problem we have in the place. The second part is collecting the data. So this data have been collected, from the different system of a company. So there is a database, available. You can think of from where we have pulled this data out. Where this data is kind of pulled out, and after that, because this is a confidential data, no company wanted to share the exact column names. What they have done is they have anonymized the data. So they have written the column names like V1, V2, V3, V4. till and so on and so forth, right? So why companies do that when they share this data in an open source world? The reason for that is no company wanted to kind of share their internal infos in the outside world like this. So that's where they have done this anonymization of the column, so that you won't be able to understand that what exactly the column is. But that's okay. That's what I said, that business understanding part, even if you're not able to get this 100% on this, other things you will be able to do with this data set. Now I am kind of loading my data set by doing df.head. This is a command which helped me in loading and seeing the top rows of my data set. Now you can see that there's a time column, there is some v1 column, v2 column. See this, all this column, right, which you are seeing v1, v2 till end of the funnel, uh, are kind of a column which is you are going to use to predict, okay, which you are going to use to predict, okay. And then finally you have an amount column, okay. Amount is the amount of transaction which have been done, and this class is your target variable here. Remember, this is a supervised problem, so we need to have a target. So this is my class variable here, okay. So if you kind of see what is the data we have in class, so I will kind of show that. So let's say I do df.class dot, let's say, value counts. If I do this command, it will show me that this have a 0 and 1 in this data set. And the zero record, zero means non-fraud. I will write it here for you guys. Zero means non-fraud transaction, okay. And one means a fraud transaction. One means a fraud transaction, okay. Now you can see from this particular data which I have loaded that fraud transaction are very less. See this, huh? Out of approximately 2 lakh 85,000 transaction, I've got only 492 transaction, which is kind of a fraud. If you wanted to see in percentages also, I like we can see that. So I will just show that also to you guys before we move ahead. Okay, so in terms of percentages, only 1.17% of the transaction are kind of a fraudulent transaction. All other transactions are non-fraud, and that's what happened with this kind of a model, because fraud doesn't happen like this, that out of 10 transactions 5 transactions are fraud. No, it doesn't happen like that. Out of lakhs of transactions you will find one fraud, right? Correct. So that's how my data set is about. Now first thing I will going to do is I'm going to check the missing values. So this is the command I am going to use for checking missing value. So if you see I have collected the data, then I'm doing a data preparation now. The third stage, if you remember guys, it was data preparation, right? That's what I'm doing right now here, checking missing values. Okay, so I just run this command. Fortunately I don't have any missing values in this data, right? I have a 0, okay. But if I have, then I will kind of apply different transformation. Then I will see the data type of my columns, whether what kind of data types this have. So a lot of data are kind of a integer in nature, integer and float. Okay, so numerical data is mostly I have. Okay, then I can kind of plot my graphs as now I'm moving into the next step, guys, which is an EDA step. Okay, EDA step. So I am trying to plot a graph here, which you can see for fraud and non-fraud transaction, which is 0 and 1. If you see one graph, you're not able to see because there are only 492 transactions, which is 0.17%, right? So this kind of a data set also known in the world of machine learning by one term. So when you're okay, I will write it here for you guys. When your one class, okay, is very low in percentage, very low in percentage, then it's called a highly imbalanced data set. What term we use, guys? Imbalanced, highly imbalanced data set. Okay, here as you see that one of my class is very, very low, 0.17%. That's why it's called a highly imbalanced data set. Okay, now again, we can now do a little bit more plotting. So like, for example, there is a column called amount. As I told you, there is a column called time. So I'm using a Seaborn library here of Python, and I'm plotting this graph. As you can see that this graph is running now. I run the code. It will give us the output quickly, and then we will move ahead. So see, this is how I have plotted. So right now, at what stage I am, guys? I am at a stage of a EDA, right? EDA and data analysis, where I am just trying to do exploratory data analysis, right? So here I can see the amount here. That amount is kind of having a very different pattern altogether. If you see, my scale is 0 to 5,000. This data is in dollars, actually. It's not in Indian rupees. That's why you may be seeing that that this is shifted, a lot of shifted on the lower band side. Similarly, for the time of the transaction, I've got this kind of a graph. Okay, this left side of a graph is a distribution of time. So again, I can keep on plotting this kind of a graphs, guys, right? I can plot different kind of a charts to understand about the data, but I wanted to communicate that you have to do this way after you have completed with your data preparation task, right? And once you have done that, then you have to scale your data. Scaling is one way of bringing all the columns at a in a same boundary as such. Same, like for example, I can give you a simplest example that, let's say if you have an age and income in your data, now age will have a different scale and income will have a different scale. What is the meaning of scale? Because the age will start from, let's say, 18, and age will go till, let's say, 110, 120, but your income will start like 5,000 rupees or 10,000 rupees. So the scale at which they are is different. So we can use different kind of a scaling method. uh, I will again not going in very detail, but kind of showing you an overview so you can read about feature scaling methods. There are broadly three methods which is available in this, which is called standard scaler, uh, your max mean scaler, okay, and one more is robust scaler. We are using robust scaler because it can handle the outliers well. It can handle outliers well. Okay, again, I'm not going in detail, guys, you can read about that, but I just wanted to show that what you have to do in the EDA part and data preparation part, right? So we have done that. Now we'll see the data. This is how our data set look like. So we have completed our EDA part in this particular example. I can keep on plotting more graphs, but let's move to modeling phase now. Now we are going to build a model. Okay, now we are going to build a model. So what first of all I will do in the modeling, as you guys have seen, that we first divide the data into multiple parts. So I'm using this particular function from scikit-learn. So scikit-learn.model selection, I'm importing train test split. So this function help you in dividing data into two parts. Okay, two parts. Okay, so that's what I have done. I have called this function here, and I've given a test size here, which means that 80% of my data will be training and 20% of my data will be test. Okay, so I have specified that. Now it has created 4 data frame for me. Xtrain means the data for my training. Okay, all independent variables in a way. You can say the variable I'm going to use. X underscore test is my data for testing. Okay, data for testing. Correct. Now it's the final time to build the model, guys. So we are going to first build a simple model, which is a logistic regression model. So I'm going to first show you that. So it's very easy again, guys. You have to first load a library again from scikit-learn. Remember, this scikit-learn is very important package if you wanted to do all these things, right? So from scikit-learn.linear model, I am importing logistic regression. And then after that, I'm simply calling the logistic regression class here. And then I'm doing a fit on my train data. If you see, I'm passing my train data. I'm not passing my test data. I'm passing my train data. Once I've done that, it has trained the model. Now, once we have trained the model, it's the time to make the predictions. Make the predictions on what? On test data. Okay, on test data. How I am doing this, guys? I am doing this again by simply using a model which I have developed here, dot predict, and passing my test data into it. Correct. And then after that, I am kind of seeing the accuracy. Remember, right? This is where I'm starting a model evaluation part to know that how good my model is. So I'm trying to understand accuracy, that how good my model is. Ideal accuracy is 100%, right? But let's see that what is the accuracy I have gotten here. So I will run this. This is running right now. It will take a little bit of time to plot to train and then show us the model evaluation. So in this particular piece of code, guys, I have done 2 steps. One is model development, which I have done from here, which is model development. And the second part is my model evaluation. Which is kind of a last before deployment, the last part of my explanation which I have done. Right now, you can see there are different kind of a matrices which you can see, but let's say we will focus on one thing, which is an accuracy. What is the accuracy I'm getting here? Okay, so as you see that I'm getting a good accuracy, but at the same time, this is a very imbalanced problem. So we need to understand how good my model is predicting the frauds. Because if you see non-fraud, it's predicting very well. So I think you can understand from this table. This table will give you a clarity. So 0 is my non-fraud, 1 is my fraud, and the predicted was on x-axis. The actual one is on a y-axis. Okay, so if you see this, 56,852, right, is the records which we have, which was actually 0 and we also predicted as 0. Great. If we talk about the 9 record, which was actually 0, but I have predicted this as a 1, which is my misclassification. I have done a wrong prediction there. Now, if you see 37, so this 37 transaction are actually 1, but I have predicted them as a 0. If you follow this graph, you will be able to read this. And then finally, 64 are the people who are actually 1, and I predicted as a 1. So what is my error here? So error is 37 plus 9 is something which I am not able to predict correctly. Right now, in this way, you can kind of build different models, guys. You can build random forest models. You can build SG boost models. You can build n number of different models out here. But if you follow the whole flow which we have discussed, from starting business understanding, then we move towards data collection, then data preparation, then data doing a EDA and analysis, data analysis, then move to model, then move to model evaluation, and then the deployment, right? So in this way, we have kind of understand the whole pipeline. We are not deploying the model here, but there is a stage where we can kind of deploy this. But you can read more about Flask and other tools as such for deploying this models once we have developed this model. So with this, I think I will kind of take a pause here. We also reached towards 4:20 now. So I think it's better that we will open up for a Q&A now. If there are any Q&A, we'll take that. But this is the whole idea about from end-to-end pipeline. So I hope this kind of a whole explanation help you guys. Now over to Siddharth, and let's start with the doubt section.
Thanks, Aryat. I think that was a very good session. So I think you have already given them a brief overview about how they need to work on a data science project from end to end. Definitely, I think we should be open up for a couple of questions there.
Sure.
So the major audience which we have here are from BTech, B, and mostly from BCA and MCA background. So
Sure.
what kind of projects do you suggest? Because they are a fresh grads who will be passing out in next year. So what are the projects which you suggest for them, which they can implement as their final year project, or for them to explore more into data science before they briefly step into the data science world?
Sure. So I think there are a couple of projects, I guess, they can pick up. So if they are interested in working with this kind of a data set, which I show, so in this, they can kind of go on Kaggle or any other platform where they can work on credit card fraud detection. That's the one which we have shown today. The second one, they can work on this credit card, loan prediction, loan approval problem. That's also one of the good problem which is out there. So that's present as a home credit problem. If they search out there, they'll find it. There is a house price regression problem which is available, they can work upon. Along with that, there are some data sets out there for a recommendation engine. They can take that and build this. So on this line, these are the data sets, but I will encourage more to work on deep learning side also. If they are interested, they can build chatbots using Rasa. They can kind of build an image classifier or image identifier type of a system. Again, all these data sets they can find out on Kaggle. If they go on Kaggle have this data set. So to begin with, they can take this MNIST data set, which is a handwritten images of the numbers like 0, 1, 2, 3, 4 till 10, till 9 basically. So all these are kind of a projects they can go ahead and try to get the data, because I think the biggest problem which they face is the data, right? So data is something they can borrow from Kaggle platform and then read couple of notebooks there and then follow the path which we have shared today to complete that projects.
Right. So to start off with the data science part, right? So what can be the primary things they have to learn? So for example, there might be few aspirants who are from a more of a commerce background, so who wants to get into a data science field. So what can be a roadmap for them? So if they want to get into a data science.
Okay, so okay, that's a very good question actually. So first of all, this thing is that okay, they may be from commerce background or they may not be from CS background, and as such, this kind of a questions are very common. And but this on a skill front, I will say that without knowing a programming, it's difficult. So programming is mandatory to learn it. If they don't wanted to focus a lot on maths in the initial part of the journey of data science, that is still okay. But surpassing this part of programming or neglecting the programming is not something which is going to help a lot. So I will say that if you are a commerce grad and if you fear a lot of maths part, let's say, you can skip that for some time. But the basic mandatory skill which you should be focusing on learning about R and Python as a language, and learn how you can do all this task which we discussed today using a programming language. And of course, there are so many things you need to learn, but you can park them for now. Focus on programming, learn a basic concepts, and move on. Once you are comfortable in building one or two solutions, then you can come back and start working on the mathematics part. But there is no solution out there that without programming language you can become a good data scientist. So I think start learning Python, basic Python, learn about pandas, NumPy, and this packages out there, and try to implement one or two solution. And in that way, they can kind of start their journey in the world of data science.
Yeah. Thanks. So I think before we wind up, so another last question. So as
Sure.
you know, storytelling is one of the key skill set if you want to be a data scientist, right? So I think,
Yeah.
yeah. So how do they develop into more of a storytelling? I know people can learn coding and data science also, but definitely storytelling is something which gives icing on the cake, right? So
Correct.
how do you what do you suggest to in order to be a better storyteller?
Okay. Yeah, sure. So, okay, so I will start with this, that data storytelling is more of an art rather than a science. Okay. Science is something you can learn, like, okay, by learning programming, syntaxes, and all. See, the person who is very clear that what's the goal they wanted to achieve. Okay. Like, for example, in the business understanding part, I focused a lot on asking the right questions and having a structured thinking. So data storytelling also follows the same path, that once you are clear with this type of a question, you can kind of understand that what the factor which is going to affect, and then you try to connect the dots together. But there is no magic recipe out here which can tell you that, okay, hey, if you do this, then you will become a great data storyteller. And I think there are so many folks who are like very good in data storytelling. They may not be a technical folks. Okay, there are people out there who know how to sell. Okay, and they know that how to create a stories using data and sell that. So I will say that the skill wise, how they can improve on that is, try to work on the structure thinking skills, try to work on domain understanding part, read a literature, read about the domain, read about what the problems they wanted to solve in. Along with that, when they try to plot all these graphs, see, plotting this graphs using a libraries is one part. Second, interpreting them and writing an insight is another part. So I will say that when they are plotting, let's say, five graphs, just try to see that how these five graphs are connected to each other, or can they connect them together to bring some story out of the plate. So these are few of the things. And again, this again, it's a common thing, right, that you have to practice a lot for a lot of things in the life to become expert in them. Same goes for data storytelling. You need to pick up one or two simple data sets, follow these practices, good structured thinking, critical thinking, read about the domain, plot basic plots, try to connect them, try to infer, try to brainstorm with different folks. And then after that, most important part is create a report, write end to end what you have done, and then try to see that how you can connect the dot and start presenting it to the different folks. If you do this for 1, 2, 3 projects out there, you will feel that you are improving day by day in terms of a data storytelling. So yeah, I think this all things doing together will definitely help you guys to move into a right direction for data storytelling.
Yeah, I think thanks, Aryant. I think that's it from our end. It was a fruitful session. I think most of the students should have benefited with this session, and we'll look forward to have a couple of more sessions with you with a very different topic, right?
Sure.
So we'll be signing off now. So all of the participants who have been attending our session, please do drop in your feedback. We will be sharing the feedback link on the comment page, and you can definitely give your feedback on that.
Okay, great. Thank you everyone. Then thank you Siddharth, thank you Imarticus team for inviting me. Thanks.
Yeah, thanks, Aryan. See you all. Have a good day.